It's blinking. Okay. Yeah, it is started. In IPv4 address, generally a lot of other things also there. So the first point is about IPv4, what is related to IPv4, a number of bits, octets, classes. Very important is class and ranges. And about zero network and 127.0.0.1, another important. How to identify the IP address and their classes. Okay, network and host portions. Subnet mask, default subnet mask. And of course, network ranges. Each class, what is there? Network ranges, number of hosts in it. Okay. And what is a network ID? Okay. Subnetting concept also. How to represent subnet mask in the slash notation. So these are also there. Okay. And IPv6 and IPv4 private IP addresses, public and private IP addresses, NAT and PAT concept. Okay. Now to assign an IP address. These are all IP addresses part only. And what is APIPA? If you got APIPA, how to troubleshoot? So these are all IP address part only. So generally, I take time to explain this network and ranges, IP address specifications, subnetting concept, basic. What is subnetting? Okay, subnet mask calculations. I'm not doing that now. Okay, so if I have a time after completion of major part, then I will explain. So what I'm going to do is we'll go to the simple IPv6 pattern. Okay, IPv6 first. Then we'll see IPv4 private and public IP address ranges. Then NAT and PAT also we're going to see. The first part we're going to see IP address. And the IPv4, IPv6 we discussed, right? Also we'll discuss IPv6 first. Then IPv4 and IPv6 difference. That is a very important question. Difference between IPv4 and IPv6. In IPv6, a lot of things are there. We'll see what the main basic points of IPv6. IPv6. Okay. So IPv6 is 128 in a binary format. If you write IPv6 in the binary, so it is 128 bit in size. So 2 to the power of 128 is, it is around 3.4 billions of IP addresses. In another name is for undecillion for that. Actually, if you write like this, 10 to the power of 38, total size is 3.4 into 10 to the power of 38. Means you type a 34, put a 34, after 34, 37 zeros. 37 zeros. That is a IPv4, total IPv4 addresses. Okay. It represented in hexadecimal format. It is a hexadecimal format. If you take one hexa number is equal to 4 binary. Generally, hexa numbers are start with a 0 to 9, then A to F. Totally, we have a 16 digits. Totally, we have a 16 digits, means 0 to F. Exactly say 0 to F. F in the decimal format, it is 50. Okay. So 0 to 9. After 9, there is no 10. A, B, C, D, E, F, like that. Okay. If you want to write 0, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. It is not alphanumeric number. It is a digits. It's a number only. Okay. In the hexadecimal format. Next. And totally 32 hexa numbers are there. Total 32 hexa numbers in one IPv6 numbers. Totally 32 hexa numbers in one single IPv6. It is divided into 8 blocks. 8 blocks. So it means 32 divided by 8. It means you got a 4. And each block contains 4 hexa numbers. Okay, each block contains 4 hexa numbers. Is 32 by 8. So I said total 32 hexa numbers in a IPv6. 32 hexa numbers divided into 8 blocks. 8 blocks. Each block contains 4 hexa numbers, right? And separated by colon. Colon. So how this IPv6 will write is an example of an IPv6. Just for example, 00 colon 1, 2001 colon something A, 203 B, 5 F, 4 2. No H's, no, only A, B, C, D, F only. No G, H, I, J, that is won't come here. 0 to 9, A to F numbers only. And 8 blocks, so 1, 2, 3, 4, 4 blocks we have written. So we have to count properly. 1, 2, 3, 4, 5, 6, 7, 8. This is how it is. And IPv6 is look like. Even small colon. Yeah, this is also a kind of IPv6 number only. Actually, that meaning is 00 colon 1, 0 colon 0 colon 0 colon 0 colon 0 colon 0 colon A. Okay, so that 0 represents actually 4 zeros. If possible, I will show you that how to rewrite the IPv6 also. This is about simple points about an IPv6. Okay, and enter IPv6. As I said, there is a 3.4 undecillion, means around 34 with the 37 zeros. That much, so many IPv6 addresses are there from starting 00000 to FFFF. Like if you count everything, so many IPv6, but not entire IPv6 addresses not released into the market. They didn't release. So who is control IP addresses? IANA, ICANN, Internet Engineering Task Force, IE, Internet Engineering Task Force, IETF. Okay, IETF, I can, these are all control this IP addresses and domain names like that. These are all control of those things. Okay. So in IPv6, what happened? There's not like in IPv4, we take from starting IP to ending IP, then we divide into the classes. But in IPv6, we didn't divide into the classes. Okay. In IPv6, entire IPv6 not divided into any classes. But instead of classes, there is a certain ranges are specified. Okay. So entire IP6 not divided into classes. So there is a IPv6 ranges. There is a classification range is there for different purpose, for different purposes. One is like for public communication. So you want to communicate publicly, you want to access google.com, facebook.com, youtube.com, you need a public IP. Okay, you need a public IP. So that is called a global unicast. Okay, that is called a global unicast address. The range is 200:/3. Okay, 200:/3. So that is the starting range. If you write that one in a simple format like this, 200. 1 second, I will make it little bigger. Okay, 0:00:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0:0 So you have to count 8 or not. 1, 2, 3, 4, 5, 6, 7, 8. Right? This is the starting /3. What is this /3? Means first 3 bits in a binary. First 3 bits are constant for entire range, and remaining will be changeable. Meaning is if you take 2000, this part, only take this part, okay, and convert into binary. So binary format into hexa this is the first one. This is the third part in the binary format. First 3 means this is the first 3 part. Okay, so you can just simply make it. This is constant. From here it is variable. Means along with these are all variable part. This is the constant for that range. Global unicast range. This is the constant one. Okay. So if you take this and put 1 here, this is 200:1 like this. This is the first number, second number like this. Okay. Once it is reaches 9, then it is become F. Okay. Once reaches F, it is again 10. It keep on going up till what number it will go. So 3. F, 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 F. This is the last number. So what is the starting number? This is the starting. Okay. And this is last. Okay. Even if you take it and convert that 3FF, okay, into the binary like 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, like this. See this 0, 0, 1 not changing. If you go to the next one is 4, means 1, 0, 1, 0, 0. It means it is changes. So that's it is. That's how it is. The range is 200::2 3FF. Okay, but that's it's not 3FF, not colon colon. It's like a colon colon means again lot of zeros are there. So 3FFF colon FFF FFF like that it will be there. So this is the total range. So this is global unicast address. Purpose is public communication. Public. So public IPv6 address. Of course, in the public IP address, which is assigned by your ISP only, and this public IP address includes network range plus your global range, means which continent you are belongs to based on that one Asia specific like that. Your ISP ID is also integrated inside the one single IPv6 address. Okay. You can try like this. You can go to Google and type IPv6 global unicast address. Okay. This is the range. Global routing prefix is 48-bit assigned to a site, a customer or an organization. Subnet ID. So what is this subnet related? Okay, interface ID. This is host ID. Okay, the host ID is often generated using EUU64 or randomly. Okay, so 64 bits belongs to host ID. Okay, earlier in IPv4 for class A, this is the host portion. For class B, this is the host portion. Class C, this is the host portion. But in IPv6, mainly in a global unicast, that entire last 64 bits are belongs to host part only, like 1, 2, 3, 4. This is the entirely host part, host identification. This is a network identification. In the network identification, what is its subnet mask, what is a global prefix, which organization it is belongs to, like that it is there. Unique local means it's a private IP. I am searching for a structure. (128-bit), each bit, what is its representations? This second one, that represents a global unicast. It is reserved by IETF for future use. That much is not that structure I'm going. Okay. We don't do that much deep dive, not required. Okay. Next one is unique local. What is this unique local? Is a private IP. Private IP are not non-routable for public use. Okay, non-routable in public, but we can use in the your private, inside your organization, inside your home, you can use the private IP without taking any license or paying of amount not required for a private IP addresses, whether it is IPv4 private or IPv6 private. You don't need to take any license or registrations or payment for a use of this IP addresses. Anybody can take private IP and use it in their own local network, in their private network. That is private IP. With private IP, like your system has a private IP, you can't communicate it to public IP directly. Okay, Google.com, Facebook.com, YouTube.com, you can't access with a private IP. Private IP for internal communication purpose only. Private to private, routable. We can route between different, like in your big organization. Okay, you have a different private networks are there. You can connect these private networks together and you can make them communicate each other. But they can't communicate outside, means public communication, they can't do it. The range is FC00::7. The 7 means again same, first 7 bits are reserved for this entire unique local range. Of course, last 64 bits for host purpose only. Okay, so that's it is. Which is non-routable in public. And my favorite, link local. Link local. FE80. This is most recognizable one. Link local. Link local. Non-routable in private, non-routable in public also. We said /10, but it is okay, anything. Actually, 7, 1, 2, 8. Okay. No specific 7 or 10. That is also confusion. I will take 10. Okay. This is a private IP address, but it is actually non-routable in both private and public. Works in a single segment only. Single segment network. It means physically, logically, same network. So I have a switch. I connected it to 10 devices, and the device using the link local. With the help of link local, we can communicate. Okay. So, but if you connect a router, so we can't communicate outside of the network, outside network of the router. Other network we can't communicate. But within that, like you connect a devices to a switch or a hub, and with the link local, we can communicate. And very important one is, it is system self-generated IPv6 address based on analysis MAC address. Based on NIC MAC address. Based on your NIC's MAC address, it generates an IP with link local IP address. Every system has their own link local IPv6 address. So I go to ncpa.cpl. You see, I have a multiple adapters. I go to my Wi-Fi adapter details. See, there is a link local IPv6 address. This is automatically generated. I didn't assign. All remaining we have to assign. But it is system generated IPv6 address. You go to this address, go to details, see, link local IPv6 address. So even if you see the adapter IP addresses, that IP address are either system generated, or maybe you have to assign manually, or DHCP server has to assign IP address. But link local is system self-generated IP address based on your MAC address. With using link local IP, you can able to communicate within your segment network, means within your physically, logically same network. Next, multicast. Multicast addresses, like we use class D, right? In IPv4 class D is a multicast address range. So here also multicast address is there for same purpose, to communicate in the group, one to many or many to many groups, like that. So for example, I have a multiple router, 10 routers configured with a RIP version 2. So this routing protocol, what it will advertise the routing information to other routers. How it will advertise? The two addresses multicast address. other how to understand what is that two address is the protocol based multicast address only, not interface based address. Okay. One-to-one communication is unicast. From my system to my desktop, if I send a packet, that is unicast, 1-to-1. System has a unicast address. Multicast means there is a 10 system. I want to deploy an application or I want to send a message to these 10 systems. So using some protocol or maybe an application. So with two addresses, multicast address here. In unicast, two addresses, system direct IP address. In multicast, two addresses that group multicast addresses. Okay. This is FD. That is FC means this is FD : // multicast address range. That's class /7/8. These are all you can verify with any other authorized one. Either you can multicast. So see, it is 07. Loopback unspecified multicast indifferent, well-known transit source list node like that it is. It is showing /12. This is what I'm trying to say. This is unicast address total. This is interface ID means host addresses. 2 to the power of 24 number of hosts we can able to make it as a single network. In one single network, how many number of devices we can assign an IP address under single IPv6 network is 2 to the power of 24 devices. We can make them in a single logical network. It is very, very bigger than your total IPv4 addresses. Because total IPv4 addresses 2 to the power of 32 only. Okay. And what about the first 64 bits? First 64 bit generally represent network. Next 64 bit represents generally host. The first in a global unicast address, first 64 bit. So 116 bit, this part is for site or a subnet ID, means which subnet you are belongs to. Not 64, that is what I said, which subnet it is. Okay. This is global routing prefix, that is organization based identity. So I wanna say that this is the total IPv6 global unicast range. Again, this is for your area. It means which geographical area. So Asia specific, ARIN, what is that? It is, we have to check it, ARIN. Okay. American Registry for Internet Numbers. Okay. American Registry for Internet Numbers, ARN range. So what about AP, Asia specific? Okay. India included steering committee, asset recovery, inter-agency network, Asia specific. Okay. Not for India, guys. It is a lot of other countries include as a global range is there. And there is a common prefixes. This generally 2400 AppNic. This is what I'm searching. AppNet as Asia specific. This one. Regional Internet Registry administration for IP addresses. You have to go to AppLink to get a IPv6 address, Asia Specific Internet Information Center. Okay, like a geo to provide routable public internet utilizing /60 the prefixes. Okay. Multicast, where I done a mistake, multicast is FF00. FD, there are a lot of confusions are there. So my mistake only. FF00/7/12. So I'm not sure. E given /10 somewhere. So forget about slash. When you see an IP address FF00, it's a multicast. If you see an IP address FE80, FE80 common for all the system, their link local IP address. Okay, no, FE81 is not also not very less. Okay, FE80 is a commonly for link local for their system link local IP address. FC002 FDFF, that is a unique local IP address. FC002 FDFF. FDFF, there is a mistake I've done. FC002 FDFF. FC or FD. It is a unique local, means it's a private IP address for private use. Global unicast address for public use. One more is there, Anycast. What is this Anycast? Normally in IPv4, we have a broadcast. The broadcast ID of a IPv4 is 255.255.255.255. Means all four octets are 255 only. 255.255.255.255. Okay, that's the last number in IPv4 address. That is a global broadcast address. But broadcast only up to the local level only, not cross. Broadcast don't cross the routers. Okay, broadcast don't cross the routers. Okay, so what is this broadcast? IPv4 broadcast is broadcast to everyone in the network. It is broadcast because if device does not know the destination address, if device does not know the destination address, it broadcasts the packets with the two addresses 255, 255, 255 like that. It is IPv4 broadcast. What are the devices connected in the network? It broadcasts to everyone. Example, my client PC, DHCP client PC want to discover where is the DHCP server. DHCP client does not have an IP address initially. Like I came to office, I turned on my laptop don't have an IP, we try to get IP from DHCP server. So what it will do, it broadcast. Yeah, it broadcast a message to every device connected in the network to get an IP address from DHCP server for everyone. Okay, with a DHCP discovery packet, it send a DHCP discovery packet to everyone. In my network, if I have a DHCP server, that DHCP server give reply to my system. So two addresses 255, 255, 255. So broadcast to everyone. And IPv6 is Anycast. Anycast means it's same as a broadcast only. It send packet to everyone. But the condition is the destination device must be enabled with IPv6. It means the devices connected in the network. Some devices only IPv4, no IPv6. Some are IPv4 and IPv6 enabled. Some are only IPv6 enabled. So the device will send a broadcast message to those devices enabled with IPv6, means IPv4, IPv6 or IPv6 only. Okay, not for only IPv4 devices. So definitely it won't send. That's called Anycast. In IPv4 broadcast, in IPv6 Anycast, near to the device system. Okay, these are the basic common information for a got devices. 7, 8. But 7 is also not a correct one. This is maybe a 10 or something. To remove this one, why we should worry about it. Okay. This is total IPv6 ranges, guys. Okay, good. I'm trying to explain this. What is this? It is actually we see in haptic region, right? So IANA said public IP is 200::3. It means the total IPv6 range for a global unicast is 200::3, like this, where we put it here, right? This is the total range. From here to there. From here to this is the last one. This is, it said it is total range. Again, in that range only, within that range, it divide the ranges based on the regional. Okay. So you see one regional, this is ARIN region. This is our regional, APNIC. This is one regional. Okay. This is one regional. So for IPv4 or IPv6, regional centers. So based on the regional, again, there is subdivision. There is a small division. 1:18. This is for ARN type. So this is not changing for entire this region. Okay. Next, in this region, there is a ISPs, Internet Service Providers. Okay. Internet Service Provider. Added there, their service provider identity there. Okay, for example, Airtel. Airtel Apnic from Apnic range. Again, Airtel added its ISP information there. Now this is, we can understand science. From ISP, we are getting internet as a individual person or maybe an organization. If an organization is taken a specific IPv6 public IP addresses, then again, organizational identity will be added there. Organizational identity is that this is a Savantis organization required IPv6 addresses. Okay, add the Savantis one ID there for a Savantis ID. Okay, so there is a Wipro organization, HCL organization, right? Different companies are there. Then, if whenever they go for IPv6 public IP, so they based on that organizational identity. ISP are handling their public customers directly. Like in my home, I need an internet. So based on my customer related, so they add that subcategories of the customer ID there. Okay, that is structure. But everything comes under first 48 bit only. Okay, this is sub, right? Okay, any like this. You are added. That's sitting and that part it will take time. This is about a link locker, loopback, and next. Yeah, I forget to add there was 2 points also, but we'll see that points here. Okay, IPv4 to IPv6 differences. IPv4 to IPv6 differences. Of course, IPv4 is 32-bit in size. Okay, IPv4 is 32-bit in size, the difference purpose, and IPv6 is 128-bit. Next, IPv4 is like a 2 to the power of 32. We're getting a approximately 4.3 billion IP addresses. Okay, but IPv6 is 3.4 into 10 to the power of 38, means 3.4 undecillion IP addresses. IPv4 represented in decimal format, and IPv6 represented in hexadecimal format. Okay. In IPv4, 4 octets are there. 4 octets separated by dot. Okay, separated by dot. In IPv6, we have a 32 hexa numbers divided into 4 blocks. Means totally we have a 4 block. Sorry, 8 blocks. 8 blocks are separated by colon. Okay, so we have a 4 octets separated by dot. Here 8 blocks separated by colon. Each block contains 4 hexadecimals, right? Totally 32 hexadecimal numbers. But here we do not have like that. We have a separated one. In IPv4 range is 0.0.0.2 255 255 255 255, and it is divided into 5 classes. But in IPv6, no, we do not divide entire range into, we didn't divide that entire IPv6 into classes. Entire IPv6, we didn't divide it. We have taken certain ranges for specific purposes. Specific purposes. Total IPv4 range is divided into 5 classes. Class A, Class B, Class C, Class D, Class C, like that. Class D is for using multicast. But here it is specific multicast range is given. Okay, there is a private IP in IPv4 and a public IP address are in IPv4 within the classes only. But in here, private IP range is different, public IP address is different. That private IP address in IPv4, I will show it to you separately. Okay. In IPv4, we have a unknown IP type, unknown. Okay, is used for unknown. Reserved IP is there, that is 0.0.0.0. In IPv6, we represent with a colon. It's not a range, so it is simply, it's a colon. In IPv4, we have a loopback. Loopback or localhost address is there, right? Loopback or a localhost. What is its IP? 127.0.0.0.1. Oh, sorry. Okay. And IPv6. This represent colon 1. Okay. Colon 1. And IPv6, IPv4. We have a broadcast. A common broadcast IP address is 255.255.255. In IPv6, no broadcast address. We don't do broadcast. Okay, no broadcast. We use Anycast IP. Okay, Anycast. Any other differences? We'll check it. No, someone send a message. We'll see. I didn't check it. Yeah. Ashita came. Okay, doctor. IPv4, you have a subnet mask to represent why represent Why typing mistakes represent network and host portion. Okay. To divide not partition, portion. Okay. In IPv6, we use prefix for that one. Prefix, a slash notation. Okay. IPv4, network and host portion based on the classes. Each class, in each class has different network host portion. Okay, by default, IPv6 mostly it is /64 only. Okay, /64 means the last 64 bits. Okay, 64 means first 64 is network. The next 64 is host portion. Guys, these are the difference between IPv4 and IPv6. Okay. I don't go to like that. It is different things, different boxes are there. This is completely IPv6 box, and this is IPv4, IPv6 comparison boxes. Okay, so you can put a boxes like this. This is the basic what is IPv4 and their range part. And this is IPv4, sorry, IPv6 range part, it is complete IPv6. And this is for comparison, I've written some IPv4 information. This is another part. Okay. IPv6, the ranges, IPv4 to IPv6 basic comparison, and this specific IP address based comparisons. One more is there, that is IPv6, what we say that zeros part. But do you understand this or not? I need your feedback. Okay. Do you understand IPv6 or not? And IPv4, IPv6 differences. If you got a question in IPv4 and IPv6 difference, can you able to give answer or not? From here also you can directly, so difference 32-bit, 128-bit, 4.3 billion, 3.4 billion, billions means undecillion or a 3.4 into 10 to the power of 38. Decimal format, hexadecimal format. Here, 4 octets separated by dot, 8 blocks separated by colon. Each, actually I have to add that one is each octet ranging from 0 to 125. Each octet ranging from 0 to 125. That part also we can add it here. We don't have a space, also can add each octet 0 to 155. Sorry, 255. Okay. Each octet is ranging between 0 to 255. And we have a 4 octets separated by dot. and the total IPv6 range divided into classes. In IPv6, we have a blocks. Each block contains 4 hexadecimal, totally 32 hexadecimal numbers. In IPv6, we don't divide entire range into classes. We have a certain specific range for specific purposes. Okay. No one is saying anything. Say something, guys. Otherwise, I don't get interested first time. This is not only just online part. You are not listening to YouTube. Okay, you want to YouTube, then YouTube classes also there. Are you there?
Yes, sir.
Then tell me, if you understand, you tell me I understand. If you don't understand, guys, you tell me just I don't understand. Okay? Everybody is important. Okay, there is one small part. We're also going to see this. I put a caps because caps look good. That's it. Yeah. This is a simple IPv6 address. The first one is the leading zeros. Generally, if you have a number, generally any decimal number, you take it 00 to 25. Where it is typing. Okay, you take like 0025. So I said 0025 rupees. How much it is? 25 rupees, right? If you take in a decimal format, you put a 2 zeros before 25. So we say 25 only. It is, you don't want that is like this is 25 only, right? So similarly, that zeros we can able to remove it. And one more like a 00250, it's a 250. So after 25, we have a zero. That's the value is there. 100. One only. So that's similar concept. We can remove the previous zeros, right? 2001 colon 20. That second zero we can't remove it. But before 2, we have 2 zeros, we can able to remove it. C 3 0, we can take it. A. And we have a 4 zeros. Instead of 4 zeros, you can put a single zero. Instead of 4 zeros, you can put a single zero. After 5, we have a 3 zeros. After 5, we have a 3 zeros. We have to keep it like that only. Here it is 0E, so you can start E. Again 0. Again C. Okay, that middle one we can't able to remove it. So this is another way of writing. But for a system, it will take it will add the zeros, it will convert into binary. That system will do it. But for us, for looking purpose, it's the same thing. Like we can write like this, system will understand. If system showing like that, we should understand. That's a simple point. Okay, this is one point. Second one. If you see there is a 2 zeros side by side. Side by side, zeros are there. We can also compress that one. Oh, sorry. 200 colon 20 colon C 30 colon A colon 5000 colon E 0 C. See it is the 2 zeros, we can make it as a single colon. So we can remove 2 zeros and with a colon. It means not only 2 zeros, guys, 2 zeros or 3 zeros or 5 zeros. If there are side by side, we can remove them and represent with a single colon only. Okay, so system will understand 2001 colon. I have a sorry 0 colon 0 colon 0 colon 0 colon 0 colon. I said no, I will going to tell you that is for a 0 colon. Simply A is there. You know what is that meaning? You can write like this simple. Both are same. So 2001. After that 0 0 0 0 and last one is A. So between 2001 and A, only zeros are there. So I can make it as single. And of course, there is a conditions. Okay. For example, you have like this 2 zeros and there is some number and 3 zeros and there is a number. What to do? Colon, colon, C, 0, colon, 0, colon, 0, colon, 2. Or you can write like this 2001 colon 0 colon 0 colon C colon 2. Okay. Either way you can write it. But what is the mistake? Mistake part also we should not write. What is the mistake? People is misunderstanding. What we should not do. This is the thing we should not do. This is wrong. Okay, either one side. If all are zeros, means from here like this entire part is zeros, okay, no problem. Put a colon. Even this is also 0, then you can put a just colon like this. 2 colon. Actually, this is 2 0 0 0 colon means this is the one. It represents this one only, nothing more. Okay, 2 0 0 colon means it is a after this, these are all zeros only. Okay. If like that, you can specify. But there's some number in between. There is 2 zeros here, 3 zeros here. In between, there is a number. So compulsory you have to check. Okay, which zeros you want to remove and put a double colon there. Like either this side or maybe this side. Okay, either you write like this or you will write like this. But you should not like this. Do it both, you can't able to remove it. Understand, guys, how to deal with that IPv6 address. So this is IPv4, IPv6 difference. And how to rewrite the IPv6 address. This one, next, this one. Okay. Yeah, this part also we are added here. Rewriting a IPv6 address. You can take different exercises online. So you can find a lot of websites are there only for that kind of practice. The next one we are going to see about private IP addresses and NAT and CAT. Take a 10 minutes of break, guys. Just take a 10 minutes of break. Uh, 350. Back at 350. If you back after 350, then I will attend attendance and I will do that.